Hello. Good morning, everyone. Good morning. Am I audible? Voice clear? Am I audible? Voice clear? Okay. So, students, in this today's class, I'll take the introduction portion of the organic portion. Okay. I'm going to take the introduction part of the organic chemistry. Uh, by this time, you have gone through the paper and you have realized that in the paper, maximum portion is from the NCRT, and if you solve the module, if you solve the assignments, then selection will be confirmed. Nothing can stop you. The only thing is that you have to continuously do the work, class notes work along with the modules. First thing. Second thing is, in the classroom, try to write the things in a systematic way, because you are in the online mode. Sometimes you are motivated, you are writing everything. Sometimes you are just lying here and there, you are just listening the lecture. That will be of less useful. So best thing is, be self-disciplined. When class starts, try to write everything. The more you write the structures, the more practice you are doing, the more you are able to recall in the exam time. That is why a lot of students, they know the concept, but finally in the exam they are not able to write the structures also in that limited frame of time, or they start forgetting the things. So best thing is, when you practice maximum by writing it. If you are not writing the structure, if you are not practicing properly, then in the exam you are going to forget lot of reactions. Clear? So best is, write down the notes properly. When you practice them, when you do self-study, then read NCRT line by line, your notes, and write down the structures again and again. Now, in today part, in basic introduction, what I will do, I'll simply go through the NCRT part. Initially, it is which chapter? It is the some basic principles in the organic chemistry, and this is a, in the new NCRT maybe unit will be different, but that is the first chapter which we are discussing today. So in class 9th or 10th, you all know, yeah, you should buy new NCRT. If you have old NCRT, no problem, go with that, but it should not be marked, because you have your own understanding, you will mark specifically. If you don't have the new, old NCRT, go for the new one, no problem. Now, going back to this one, in the introduction part, today we are discussing just simple things like what is the meaning of catenation, or why carbon forms so many or numerous compounds. So what is the reason for that? Why carbon forms numerous compounds? Because of which property? A unique property, which is known as catenation. What is catenation? Catenation is simply what? That carbon combines with other elements like oxygen, like with itself also it combines with carbon, with nitrogen, with sulfur, with halogens. So carbon is forming long carbon chains, or it is bonding with other carbons easily. And it forms single bond, it forms double bond, it forms triple bond. So this property of self-linking of carbon is known as catenation. Okay? Now, which factors are favorable for catenation? The factors which are favorable for catenation is, due to small size of carbon, it is easily combining with other elements, with itself also combining, with oxygen also combining, with nitrogen also combining. So because of its small size, the overlap is good, and it is forming bond with itself and with other elements also. Okay? Then it forms single bond with itself, it forms C double bond, C alkene also, and it forms C triple bond, C alkyne also, and their bond energies are high. Means stable compounds are formed, or strength of bond is more. So these are the favorable factors that carbon form long chains. Which one? The carbon forms long chains because of the strength of bonds are good. It is able to form multiple bonds with itself, with other elements also. So this is generally going the term which is catenation. Now you don't have to write anything catenation is what, because it is just the introduction part, already you know from the junior classes. Right? Now this property is catenation. Then in general introduction, what is given here, that initially scientists thought that organic compounds can only be obtained from plants and animals. Old theories, not useful. Initially they thought that we cannot prepare organic compounds from the inorganic substances. And some scientist, that name is given here, Berzelius. Berzelius gave the concept of vital force. That was flawed, old. So that initially they thought like this, that we cannot prepare the organic compound from the inorganic substances, and Berzelius said that they are requiring some vital force. Because of that, it is required for the preparation of the organic compounds from plants and animals. Later on, which was prepared later on, scientist name is Wöhler. This one. Wöhler synthesized urea from the ammonium cyanate. So that is how from the inorganic substance he has prepared the organic substance, and that theory of Berzelius was discarded. Okay, then further Kolbe synthesized acetic acid and methane was synthesized by Berthelot. No more details are given, which reactions not useful for us. So you have to realize by this time that lot of things are information based. That information is only relevant for us. Their background is nothing given. So we will not waste our time in any of the background information. Which is relevant, our focus will be straightforward for that. We are preparing with a purpose for NEET 2024. If your purpose is clear, then you will know that which things you will not be indulged in, so that it will not be a waste of time. Okay, the NEET 2024 is your purpose clear, straightforward, hit it, whatever required as per the NEET level, I'll do it. Whatever extra information given, that is purely extra, I will not focus on that. If you have a time, you can read for extra information. Then next part is tetravalency of carbon. That carbon forms how many bonds? 4 bonds, right? They may be all single bond, they may involve multiple bonds, but it can form maximum 4 bonds. We can understand it by the configuration also. So here hybridization part is given. Hybridization we will discuss in chemical bonding. So we are not going to talk about the hybridization concept because we are doing the introduction part. So I will better focus on the part which is the how to write these structures like this one. That is a better portion for us, that structural representation, that in which ways we can represent a particular formula. Like one of the way is that we will write its expanded form. Each bond we will show. Other way is we can write the condensed form. And other way is bond line notation. Getting it? So in today's introduction, when you read the NCERT, I'm just going through that portion so that after the class, you can read this part also. Right? Getting it? So here it is. So in the introduction today, in the basic introduction today in the organic chemistry, firstly, basic definition. What is the meaning of organic chemistry? It's a chemistry of carbon. Mainly carbon and hydrogen are there, along with some other elements may also be present. Which other elements can also be present? Oxygen, nitrogen, sulfur, phosphorus, halogens. So it's a chemistry of carbon. and hydrogen along with some other elements may also be present. That is termed as separate branch, which is organic chemistry. ठीक है? No need to write all those things. Just I'm telling the basic introduction part. Which thing you can write is the structural representation. Is the structural representation. Structural representation में one way is expanded form. One is expanded structural form or expanded structural formula. In this type, we will write the every bond, because by this time you all know bonds and everything. Detailing we are not doing, just general meaning, bonds are involved. And easiest example, if I give you example of ethane, which is C2H6. C2H6 is a what? C2H6 is a molecular formula. ठीक है? C2H6 is a molecular formula. If you have to write every bond, every connectivity of C2H6, then this will be termed as expanded structural formula or expanded structural form or expanded structural representation. ठीक है? Like C2H6 ethane, you all know. So when you write the every bond, every connectivity in C2H6, that is the meaning of expanded structural representation. Expanded structural representation. This is the meaning of expanded structural representation of ethane. If I say it is C2H4, which you all know, it's the molecular formula of ethene. So I can write it in this manner. This is which one? Expanded form of, it is expanded form of ethene, C2H6. ठीक है? If I say it is for pentane, C5H12. Straight chain I am writing, not the branched one. We are doing systematically the basic representation. So C5 may you will write 5 carbon straight chain. Other possibilities are there. I'm not writing all others. Writing the straight chain of N-pentane, and other connectivities are written in this manner. This is what, that is the meaning of which form? Expanded structural form or expanded structural formula. Clear? So this is the meaning of expanded form. Whatever we are doing, you can also read from NCERT. So whatever class timings are given, you will go through that portion from the NCERT also. Although it is basic part, but always make the habit that you will read the standard language of NCERT. You will not miss that language, because in exam standard language is always used, so you can relate it or you will respond very fast. Because whatever we are doing, it has relevance with the preparation. So every lecture has a huge relevance with the preparation. So be alert, write down everything, listen to it carefully. C5H12, okay, this is written. Then we can talk about the another representation, which is condensed structural representation or condensed structural formula. Now we talk about the condensed structural representation. or condensed formula. What is the meaning of condensed structural representation? In condensed, we are not going to write the bonds individually. Wherever required, like double bond is there, that we have to show. Otherwise, carbon chain with other carbon, sigma bond, no need to mention. For example, in C4H10, this is which one? Butane. ठीक है, butane. You can write it in which manner? CH3, CH2, CH2, CH3. It is also condensed form. Or you can say CH3, CH2 twice CH3. Here we are not showing all the bonds. That is the meaning of condensed structural form. C6H14. So if you have to write the straight chain, I'm talking about straight chain, hexane. So you can also mention it like CH3, CH2, 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 and CH3. Or better way is even more, you can mention CH3, CH2, 4, CH3. That is the condensed structural form of straight chain of 6 carbon, which is hexane. Getting this one? This is the condensed form. I'll give you mixed questions. Firstly, understand the meaning, which you all know, but just a reminder for you, just a quick revision for you. This is basic terminologies are used. Third representation is bond line. Bond line formula or bond line representation. Now, bond line means in bond line, we are not going to write carbon and hydrogen. Normal carbon, we are not going to write. If any other atoms are present, that we have to show. So, in bond line notation, every corner of the chain, every vertex represents carbon. Every corner or every vertex represents carbon. Like if I talk about C3H8, which is propane. So we can represent in bond line notation in this manner. Every corner is carbon, every vertex is also carbon. It is understood that whatever valencies are there, they will be satisfied with hydrogen. Like this is written, it means what? Carbon here, carbon there, carbon there. Its meaning is this one. Valency completed by hydrogen. This carbon has formed one bond with other carbon. So how many left out? 3 left out. Valency completed. So understood, every terminal carbon is CH3, bond line notation. This carbon has 2 bonds with other carbon. So remaining 2 has to be satisfied with hydrogen. So you can mention it is CH2. Other one again CH3. So basically this is easier way to write in the notes also. So whenever we write, we maximum try to write the normal bond line notation. It's also a representation. So this is propane. CH3, CH2, like this one. Similarly, if you write for C5H12, bond line notation, straight chain I can write like this. 1, 2, 3, 4, 5. You can write any, like you can write zigzag pattern other. It won't matter. Main thing is correct terminals and correct vertexes has to be there. It is first, suppose it is second, it is third, it is fourth, it is 5. That means okay, carbon, 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 5. Then remaining valencies will be satisfied with hydrogen. Same way, if you want to write for, like if you want to write for CH3, CHOH, CH2, CH3. For this compound, if I want to write its bond line notation, so firstly I'll write carbon chain 4 carbons. I'll write 4 carbons, 1, 2, 3, 4. And on second carbon, OH is there. So that hydrogen which is connected to other element, that we have to show. CH3, CH, this is carbon here, CH3. This carbon, CH, OH, then CH2, CH3. Getting this one? Other example, if it is there, CH3O, CH2, CH3. If you want to write its bond line notation, you will write what? CH3 carbon, CH3 here oxygen, here CH2, CH3. This terminal carbon bonded to oxygen, then further carbon singly bonded to other carbon. CH2, CH3, CH2, CH3. Here it is oxygen, then CH3, CH3. That is the meaning of bond line notation. Now, up to this point, are you getting it? Can I change the slide? Syllabus will be same in online and offline, but sincerity level generally more in the offline. I have written a question. Try to write down. This is the condensed form given. Write down its bond line notation. Same way, another given condensed form, write down bond line. Write down its bond line notation. Now, first one, I hope by this time you have completed CH3 thrice CH. If I write its normal carbon chain structure, you will get CH and CH3, CH3, CH3. So in bond line, you will maintain this. This carbon here. It is bonded to three other carbons. Either you can write like this or you can write like this, all are same. This is middle carbon. It is bonded to three other terminal carbons, CH3, CH3. That is the one such representation. Second example, I'll write the answer directly now. You will check, are you getting the same similar one, maybe some zigzag pattern may be different, no issues with that. Completed. Second example, I'm writing the structure, but before I write, your attempt has to be there, then only it is useful. Otherwise copying directly, it's of no use. Example keep on changing. Bolo. Second example completed from your end. Very good, Manish, very good. Okay, I'm writing the answer, check your answer. It is given CH3 twice with CH. So here I can write CH3 twice CH. Further bonded to another carbon, and this carbon bonded to 3 other carbons. Now check your answer. CH3 twice, CH3 twice, CH, CH. Carbon, no hydrogen. Why? Already 4 bonds are there. CH3, CH3, CH. It is one such way of writing it. Getting it? First and second example. Shall I write third one, or you want to try third and fourth? Okay, I'm writing the third one. You will check your answer. It is CH3, then CH2 thrice, CH3, CH2 thrice, CH3, 1, 2, 3, CH2 thrice. Then after that CH, 1, 2, 3, CH, CH is here, this one, and CH3 twice, terminal 2 carbon, CH3 twice, CH, CH2, 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 CH3. That is how bond line notation is written. Now fourth. In fourth, apart from carbon, one bromine is there and one cyanide is there. So mention them properly here. 1, 2, 3 carbon. 1, 2, 3. On second carbon, Br. On third carbon or first carbon, cyanide. That is the representation, bond line for fourth question. Try next one. Now multiple bond. Suppose this one. CH3, CH double bond, CH2. Write down the bond line notation. Very good. Those who are getting all correct, keep it up. Fifth one, bond line notation. Try this one also. Write down their bond line notations. Okay, question number 5th. In 5th, it is double bond given, and we have to write this structure in the bond line notation. How many carbons? 3. So I'll write firstly 3 carbons. Written. Now on the first and second carbon, double bond. Any side you can mark. That is the meaning of. It is CH2, CH2, CH, CH, CH3, CH. It is one way. You can write another zigzag pattern. That is also correct. This is the meaning of representation of bond line for alkene. Now try sixth, seventh. Try sixth and seventh. In sixth, here you can write in this manner also 1, 2, 3 between first, second, third, fourth. Second and third double bond. It's one such way, or you can also write like this. Both are possible. Both are correct. This is bond line representation for question number 6th. 7th May. In 7th, 4 carbons in straight line I can write in this manner. Then on second carbon Cl. And here one double bond. Other possibility here also CH3 is there. That is the representation for this compound. Maybe you can write Cl there, CH3 there, it has no issues, but connectivity is correct. Clear up to 7th, it is double bond given. After 7th, I have given triple bond also. Because when you read today NCERT, then triple bond is also given. So up to 7th, I have done. Try 8th question. I hope you are getting the meaning of bond line notation. Now next one. Next one is 3 carbons. So I can, but remember one thing, they are, here I have to use hybridization concept, that this is sp hybridized carbon. If you remember this, then you can easily relate. Otherwise, when regular classes will do hybridization, then you will understand. So sp carbon, if you remember, it is of linear geometry. Sp carbon is of linear geometry. So we will not write zigzag pattern where sp carbon is present. So here 3 carbons are there. So you can mention it like this. This is 1, 2, 3. So here it is 1, 2, and this is third carbon. Reason is to maintain that 180 degree. Here these 2 carbons are straight with respect to each other, and whatever bond they form further, it has to be 180 degree with them. After that you can write zigzag pattern, no problem. But if sp carbon is there, then we have to write straight, not zigzag pattern with sp carbons. Okay, that concept is from the hybridization, that sp carbon is having bond angle 180 degree, linear structure or linear geometry. Now in ninth, 4 carbons are there. I can write the structure in this manner. Double bond here, double bond there. That is one such way of representing. In 10th question is CH2, CH, CH3 double bond. So here you can write hydrogen. Na? valency completed. CH. Valency has to be completed. ठीक है? Clear now? Valency is completed. I have not written H. You can write H there. You can write any other Cl, Br. It will be sufficient. So try to write the structure for 10th. Then you can write expanded form of cyclohexane. Expanded form of benzene. Getting it or not? These are basic terms. These are basic terms which are required during the reactions. In NCERT also given. So whatever we are discussing, you can read after the class NCERT line by line. Still read line by line. Here 1, 2, 3, 4, 5, 6. So firstly I can write 6 carbon atoms. Then first carbon CH2, then further it is double bond CH. Then carbon is there CH3. One, I am just trying to write on the same pattern. But one mistake I have done, that here I should गड़बड़ हो गया. sp carbon is there, so I have to maintain that. 1, 2, 3, 4, 4. 1, 2, 3, 4 CH. Then it is 5, 6. Yes. It is 1 CH2 double bond CH, then carbon CH3. Then here double bond. And then it is single bond. Yes, correct. 1, 2, 3, 4, 5. It is one such way. It is one such way. Numbering I have done just to make you understand that numbering, if one here, so this is one carbon here, not as per IUPAC. Even in this IUPAC is also correct. Yes. In this 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, double bond getting here. 1, 2, 3, yes. Huh. As per IUPAC also numbering correct. Yeah. So here, this is the bond line notation for this compound. Getting it? Now try 11th and 12th, which is expanded form you have to write for cyclohexane and benzene. Triple bond is not the first priority here. Although, remember, today we are not discussing the priority as per IUPAC. Here numbering given just to compare the same carbon here one and here one. But if you remember IUPAC nomenclature, then or in IUPAC nomenclature, we will discuss this point. Then also numbering is correct as per IUPAC. Double bond is here is preferred as compared to triple bond there. How, that point we will do in the IUPAC notes, in the IUPAC concept. Expanded form of cyclohexane is this is the carbon atom. Each vertex is carbon and the valencies will be completed by hydrogens. Getting it? Same way. In benzene structure. Keep on checking your answers. Wherever it is wrong, correct it. Here double bond mentioning as it is as given in the question, and remaining valencies will be satisfied with hydrogen. Completed? So these are some questions we have discussed. Now, in the NCRT, up to 12th completed. Very good, all are right, very good. Here, when you read this part, you will go through this example completely. These are the examples given. Here, what is mentioned, zigzag, meaning of that in bond line notation. Okay? Then, these are the form given. It is bond line, it is the carbon representation. Then you will try these questions. After the class, you can try these questions. 12.4 you can try, 12.5, 12.6. These are the questions you can try after the lecture. Then this is not useful right now, three-dimensional model and everything. Now, classification we will do in the regular classes. Okay? In the regular classes, we will do the classification. The other point we can do is the bond line notation. Then we can talk about now we can talk about degree of carbon and hydrogen. So here we are going to use some terms. During the reactions, we can again use them. So what's the meaning of degree of carbon here? So we represent it by different ways, like if it is said primary carbon is there. It is represented by 1 with a degree, primary carbon. Primary carbon means the carbon which is bonded to one other carbon. Carbon bonded to one other carbon or no carbon. And this is given in the NCERT also, primary carbon, carbon bonded to one other carbon or no carbon, is termed as which degree? Primary carbon. Secondary carbon means the carbon bonded to two other carbons. It is the meaning of secondary carbon. Carbon bonded to two other carbons. Carbon bonded to two other carbons is known as what? Which degree carbon? Secondary carbon. Then tertiary carbon. Tertiary carbon represented by 3 with degree. It is carbon bonded to how many other carbon? 3 other carbons. Carbon bonded to 3 other carbons is termed as which one? Tertiary carbon, and last one is quaternary carbon. Quaternary carbon, 4 with degree, and this is bonded to 4 other carbons. So primary carbon, when we say that carbon is bonded to generally one other carbon, it is also primary, or if it is not bonded to any carbon, it is also termed as primary carbon. Secondary carbon means that carbon bonded to 2 other carbons. Tertiary carbon means that carbon bonded to 3 other carbons. Quaternary carbon means that carbon bonded to 4 other carbons. And whatever is the degree of carbon will be the degree of its hydrogen. Getting it? Whatever is the degree of carbon will be the degree of the hydrogen. So hydrogen can be primary. Why? If it is bonded to primary carbon. Hydrogen can be secondary. If it is bonded to secondary carbon. Hydrogen can be tertiary. It is bonded to tertiary carbon. But hydrogen can never be which one? Hydrogen can never be which one? Hydrogen can never be which degree? Very good, Darshini, very good. It can never be quaternary hydrogen. Why? Because with quaternary carbon, there is no hydrogen. Very good. So here you can mention this point. Degree of hydrogen is same as that of its carbon. Degree of hydrogen is same as that of its carbon. So in the question, identify primary, secondary, tertiary carbon and hydrogen in the structures. Identify the degree. In first, second, third, every terminal carbon is always primary because it is bonded to one carbon or one other carbon. This is primary, it is also primary. Then secondary, and this is also secondary. So how many primary carbons? 2. How many secondary carbons? 3. How many primary hydrogens? How many primary hydrogens are there? 6. 3 here, 3 there. How many secondary hydrogens? 6. Clear this example? So by this way, you can compare or you can find out the degree of carbon and hydrogen. Try for next one. Same way. Find out primary carbon, secondary is there or not, find out tertiary is there or not, quaternary. Primary H, secondary H, tertiary H, because quaternary H is not there. ठीक है, check your answer. Firstly, I am marking primary, 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 primary. This is bonded to 3 other carbons, so it is tertiary carbon, 3 degree. It is bonded to 4 other carbons, quaternary. That means no secondary. Here, how many primary carbons are there? 3 plus 2, 5. How many secondary? No. How many tertiary? 1. How many quaternary? 1. Primary hydrogens 5 into 3, 15. Secondary not there. Tertiary how many? 1. ठीक है? Similarly, third one. Primary, 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 primary. Tertiary, tertiary. And then it is secondary. So here primary carbons how many? 4. Secondary carbon, tertiary carbon. Primary carbon 4, secondary carbon 1, tertiary carbon 2. Hydrogen, so you can easily find whatever is the degree of carbon. 4 primary carbon, 4 into 3, 12. Secondary carbon 1, that means into 2. Tertiary carbon is R2, 2 into 1. So here primary hydrogens 4 3s are 12. Secondary hydrogens 2 and tertiary hydrogens again 2. Generally, these terms we are going to use generally in the normal aliphatic carbon chain, saturated carbon chain. Generally, we do not use for benzene or alkanes, but if it is given like benzene given, so carbon, each carbon bonded to 2 other carbons. So benzene carbon will be which degree? Secondary carbon. But such examples rarely you are getting. But which is important? That type. Normal alkane examples are used in the reactions. Clear? So that is the meaning of the degree of carbon and degree of hydrogen. Now, next part is, in the next part, I'll give you idea about sequence of the top nomenclature. Sequence of the IUPAC nomenclature. Details we are going to discuss in next class about the nomenclature. Today we are discussing the systematic IUPAC nomenclature. What is the sequence of the parts used in that? So it consists of prefix, root word and suffix. That is the part initially, that prefix is there, root word is there, and suffix is there. In this sequence, we use to write the systematic nomenclature, which is given by body, which is IUPAC, International Unit of Pure and Applied Chemistry. So here, firstly you write prefix. How many types of prefixes are there? Two. Secondary prefix, primary prefix. Then root word is there. Then suffix, primary suffix and secondary suffix. Clear? So in this case, we are going to follow this pattern, that firstly we identify in the parent chain what is secondary prefix, then what is primary, write it down after that, then root word, then primary suffix, and then secondary suffix. So what is the meaning of primary, or what is the meaning of secondary prefix? Any one of you? What is the meaning of the primary, or what is the meaning of the secondary prefix? What does it says, or what is the representation of that? What is the meaning of the secondary prefix? Okay, one student said it is cyclo. Cyclo is used for primary prefix, not secondary prefix. Functional group and name. Functional group name and substituent. No. Primary and secondary prefix. So firstly tell it is secondary prefix. Functional group. Incorrect, Manish. No. Secondary prefix. Let us see how many of you are awake and how many of you are able to recall from the last year what's the meaning of the prefix, root word and suffix. Okay, one student said rightly. Very good, Sajid. Any other student? Very good, Durga Prasad. Very good, many men in the cyclone. Money in the cyclone, okay. Very hydrocarbons, okay. Sujata, correct. Di, tri, okay. Sriram, presence of functional groups, incorrect. Substituents, very good. The answer is the part of the parent chain which is not in the part of the carbon chain which is not in the parent chain is termed as the substituent or branching. So secondary prefix means, or it represents what? It represents substituents or branching in the which chain? Parent chain, because we have to select the parent chain, and whichever is substituent there or branching form is there, it is termed as what? Secondary prefix. What's the meaning of primary? Primary prefix represents, or it is used for cyclic compounds. Used for cyclic compounds. Used for cyclic compounds. And what is used? Cyclo is used. What is used? Cyclo, what is used? ठीक है? Then root word. What is the meaning of root word? Root word represents what? It represents number of carbon atoms in the parent chain. What it represents? Number of carbon atoms in the parent chain. When you say pentane, so parent chain has how many carbons? 5. Pent. That pent is the root word. ठीक है? Root word represents number of carbon atoms in the parent chain. Then primary suffix represents what? It represents, very good, saturation or unsaturation present in the parent chain. Saturation or unsaturation. In the parent chain. Saturation or unsaturation in the parent chain. Like ane, ene, ine, etc. Ane means saturated chain, ene, ine, unsaturated chain. ठीक है? And last is secondary suffix, which represents functional group. Functional group present in the parent chain. Which represents functional group present in the parent chain. Very good. Yes, correct it is. Very good. So that sequence we have to follow while naming the compounds as per IUPAC. Secondary prefix, primary prefix, then root word, then primary suffix, and then secondary suffix. So mainly in next class we will discuss somewhat in detail, lightly, because introduction class is going on. Then in actual IUPAC we will discuss every functional group. Firstly we talk about basic portion, alkanes, okay? Then unsaturated ones, alkene, alkyne. Then cyclic compounds, and main part then start will be functional group from the carboxylic acid up to amines. Okay? So that part is crucial, which will be discussed in the regular classes. In introduction, I am just trying that, yes, little bit part which is not going to, you will not feel much is missed. Main thing is that. Okay? Done. So in today's class, we have done from the NCERT. I'll tell which page number you can go through again, or you can read NCERT now onwards. You will go through this one, which is this part completely. Structural representations completely you will read along with the questions given here. Then you can read which portion there. You can read this portion. What is the meaning of functional group? You can read what's the meaning of homologous series. These are the basic terms, right? Then you can read this portion, IUPAC system, initial portion. Okay, that portion you can tick it. You can read that portion. This page you can go through up to this page only. Remaining though I will start also. Okay, so I hope that today's lecture somewhat you get the idea, but with regular classes, be more sincere, be more disciplined. Till NEET 2024 exam, your no deviation, no distraction from the studies. That's the main thing for you. If you are focused, if you keep yourself very disciplined in the class, after the class, you're working sincerely, no one can stop you from the selection. Okay? Yeah, Shriram, I'll be there, yes. Yeah, in the new book, chapters are removed. Let's see what finally they are giving. No update is there from the NTA till now in the syllabus. Yes, Sriram, yes. If you are getting the new NCERT, go for it. Old NCERT, if you have, keep it. Batch, it will be informed. Regular class, maybe next class is also introduction like this, and then it will be regular classes. Okay, done. So this is just like, before the actual game, a warm up session is there na. It's like this only, है ना? I remember in school time, like this, some any game you participate, na, your coach will say, do good warm up. So today we are doing the only warm up session. Next session, next class also it is warm up for you, introduction. Then regular game will start. Okay, students. I hope you are enjoying at home. So be more sincere, because in online mode it is very difficult. Nobody is seeing you. Only you are there, and I am here. I am not seeing your parents are also not able to keep a track on yourself. So be honest, be sincere, work regularly, and that's what I say. Nothing can stop you. Then you will be selected with a very good marks. Okay. Bye. Okay. See you soon in the next lecture. Bye bye. Take good care of yourself.